Welcome to David Alexander Maths Tuition. This is chapter 6F, Circles and Tangents. Okay, so chapter 6F, things are starting to get a little bit trickier here. So if we want to show that this triangle has a right angle and we've got the coordinates of points A, B and C, then what we can do is work out the gradients of AB, BC and CA. And if there's a right angle, then two of the lines will be perpendicular to each other. So first of all, let's work out the gradient of AB. So change in y over change in x, 8 take away 7 is 1, negative 2 take away 7 is negative 9. So that is minus 1/9. What about BC? So the gradient of BC is 7 take away negative 1, so 7 plus 1, which is 8, over 7 take away negative 3, so 7 plus 3, which is 10, so 8/10 or 4/5. And let's work out the gradient of AC. So AC, so change in y, so 8 take negative 1, so 8 plus 1, which is 9, over change in x, so negative 2, subtract negative 3, so minus 2 minus 3, so minus 2 plus 3, which is 1. Okay, so we can see that AB and AC are perpendicular to each other because one gradient is the negative reciprocal of the other. So if they are, we've shown they're perpendicular, so therefore at A there is a right angle. Okay, so what that means is, here is A, so B, well, it doesn't really matter if I label them incorrectly, but we can see that this is a line going down, so this is B and this is C. Now, if we think back to our circle theorems, so there is the right angle there. The angle in a semicircle is a right angle. So if this is a semicircle, so let me show you what I mean. There we go. So if this is a semicircle, actually not a bad semicircle that, then the center of the circle is the midpoint of BC. Okay, so what is the midpoint of BC? So midpoint BC, so what's midway between 7 and negative 3? 7 plus minus 3 is positive 4, half it 2. What's halfway between 7 and negative 1? That is 3. So the midpoint of BC, otherwise known as the centre of the circle, is 2, 3. So therefore the equation of the circle is going to be x take away 2 all squared plus y take away 3 all squared equals the radius squared. So now we just need to work out what the radius squared is. Well, we know that the midpoint here is 2, 3, and we can pick any of these points, A, B or C. I'll go with B because the numbers are positive. So the length of the radius is going to be, we can just use Pythagoras here. So 7 take away 2, which is 5, so 5 squared plus 7 take away 3, which is 4 squared, and that is, so if I was trying to work out well, first of all, let's work out what this is. So that's going to be 25 plus 16, and 25 plus 16 is 41. Now usually we would square root this to work out the radius, so the radius itself would be the square root of 41. But here we want the radius squared, so actually we can simply say that x take away 2 squared plus y take away 3 squared is 41. Now, people do get a bit tangled up between working out the radius and the radius squared. Remember that the radius squared is what is needed in the equation of a circle. Some of you, it's acceptable when you're inexperienced to square root it to work out the radius and then square that, and you realise, oh, actually, I'll just square root of something to only then go and square it. What's the point in that? So this number here, that is our r squared. Anyway, the equation of the circle is x take 2 squared plus y take 3 squared is 41. Okay, so here we are into some new territory. So we've got the points and they lie on a circle. So let me just label them. So A is negative 2, 1. So there is A there. B is 4, 3. And C is 10, negative 5. There we go. Right. So find an equation for the circle. Now, to work out the equation of a circle, we need two things. We need to know the centre, and we need to know the radius. Now we don't have either of these. Now we can work out the centre of the circle. Now this is the new knowledge. If I draw the line A to B and B to C, now the perpendicular bisectors of these lines, if I just draw these in, this is not going to be particularly accurate. The perpendicular bisectors of these chords meet in the centre of the circle. So, I've not drawn it massively accurately, but that's the key bit of knowledge. If you have two chords, their perpendicular bisectors meet at the circle's centre. So I want to work out the perpendicular bisector of AB. So first of all, I'm going to work out the gradient of the line A to B. So the gradient of A to B, so AB gradient, I'll just write grad for short, is 3 take away 1, which is 2 over 4 take away -2, which is 6, which is 1/3. Okay, so the gradient of A to B is 1/3. Therefore, the gradient of perpendicular bisector, I'll just put the perpendicular bisector of AB is going to be -3. So therefore, the equation is y equals -3x plus c. Now, it goes through this point here, which is the midpoint. So let's just write down here the midpoint. I'll put MP of AB is, okay, 4 plus -2 is 2, half it 1, midpoint of 1 and 3 is 2. Okay, so therefore y take away 2 equals -3 lots of x take away 1, so y is -3x plus 3 plus 2, so y equals -3x plus 5. Okay, there we go. So the equation of this line here, which is the perpendicular bisector of AB, is y equals -3x plus 5. So I'm going to do exactly the same thing for BC. So BC gradient, there's a lot going on here, so it's important to label everything clearly so you don't confuse yourself or the examiner. So the BC gradient is 3 take away -5, so 3 plus 5, which is 8, 4 take away 10, -6, so that is -4/3. So therefore the perpendicular bisectors gradient will be y equals 3/4 x plus c. Okay, so I want the midpoint again. So the midpoint of BC is midpoint of 4 and 10 is 10 plus 4, 14, half it 7. 3 plus -5 is -2, half it -1. Okay, so y take away the y coordinate, so y take away -1, y plus 1 equals 3/4 of x take away the x coordinate, which is 7, so y equals 3/4 x take away 21 over 4 take away 1, so what we have is y equals 3/4 x take away 17 over 4. Okay, so that is the equation of, sorry, not that line there, it is, sorry, I should have drawn it, this line here. There we go. Okay, so we've got the equations of the two perpendicular bisectors, so therefore now we are in a position to work out the coordinates of where they meet, which is the centre of the circle. So what I'm going to do now is just delete all the ink just so I've got a little bit of room to manoeuvre. Okay, that's a little bit better. So again, the equations of those perpendicular bisectors were y equals -3x plus 5 and y equals 3/4 x minus 17 over 4. So where they meet is where -3x plus 5 equals 3/4 x take away 17 over 4. I'm going to multiply through by 4, so minus 12x plus 20 equals 3x take away 17. I'm going to add 17 to both sides, and I'm going to add 12x to both sides. So therefore, if 15x equals 37, then x is 37 over 15. and just substituting this into either of the two equations. I'll just use the easier one here. Then y equals negative 12 over 5. There we go. So we have our coordinates of the center of the circle. Again, let's just show this. So here is A, here is B, here is C, and we've just worked out the equations of the perpendicular bisectors. Okay, so what is 37 over 15? I doubt my diagram is particularly accurate. So that is 2.46. Okay, well that's sort of vaguely believable. And the y coordinate 12 over 5, minus 12 over 5, of course, is 2.4. So actually it's a pretty decent effort on this one here. So I've got the coordinates of the center of the circle. So now I can do the equation. Again, I'm just going to quickly delete everything. Okay, so the equation of a circle. So remember, these are this is the center, 37 over 15, negative 12 over 5. So the equation of the circle is x take away 37 over 15 all squared plus y plus 12 over 5 all squared equals the radius squared. So now we just need to work out the radius squared. So again, we've got the circle center here, which is 37 over 15 negative 12 over 5, and we can pick any point. I'm just going to pick B because it's got nice coordinates 4, 3. So again, we now are just going to use Pythagoras to work out what the radius squared is. So if I was working out the radius, I would be working out the distance between 37 over 15 squared plus the distance between the y coordinates squared and they're square rooting it for the radius. I just don't need to do that square rooting at the end. Okay, so 4 take away 37 over 15 is 23 over 15. So 23 over 15, that is going to be squared in a minute, plus what's the difference between negative 12 over 5 and 3. So that is 3 subtract negative 12 over 5, or plus 12 over 5. And that's 27 over 5. And I am going to square that. Sorry, if you're slightly confused by this, then all I'm doing is just working out, turning it into a right angled triangle. So this radius length here is this distance squared plus this distance squared, square rooted. But I'm just not going to square root it because I don't want the radius, I want the radius squared. So 23 over 15 squared plus 27 over 5 squared, and that is 1418 over 45. So the radius squared is 1418 over 45. So that is the equation of the circle. So quite a bit of work involved, and again, it's really important. I probably didn't model it brilliantly because I'm limited with the amount of space here, but to clearly label things like gradient of the line AB, gradient of the perpendicular bisector of AB, etc., etc.